All right. So good evening, everyone. Welcome to tonight's Asian Women Advancing AI Innovate and Advance series, where we have trailblazing women in AI come and chat with us. I'm Uvika Sharma, and I'm super excited to be hosting this session alongside my wonderful co-host, Padmini Soni. We have a very special speaker tonight, so I cannot wait for her to get started on this. So thank you so much for spending the evening with us. Here's how things are going to flow tonight. Padmini is going to introduce our rockstar speaker shortly. We'll have about 30 to 40 minutes of presentation, followed by open Q&A. So feel free to drop your questions into the chat anytime. And just a quick reminder to please stay on mute unless you're speaking, during the Q&A. And with that, I'll hand it over to Padmini to introduce our amazing speaker.
Thanks, Uvika. Hey, everyone. Welcome to today's session hosted by the Asian Women Advancing AI. We're here with the amazing Aishwarya. So I'll introduce Aishwarya. Aishwarya Naresh Reganti is a founder and former applied science tech lead at AWS, where she led initiatives to develop and deploy production-ready generative AI solutions for enterprise clients. With over 10 years of experience in machine learning, she has published more than 35 research papers at top-tier AI conferences, including NeurIPS, AAAI, and CBPR. She has taught professional courses on generative AI at institutions like MIT and Oxford, and her free courses have reached over 20,000 learners globally, forming the foundation for academic programs and enterprise trainings alike. Recognized as one of the most prominent voices in enterprise AI, Aishwarya has over 100,000 followers on LinkedIn and is a sought-after speaker at global conferences, including TEDx, MLOps World, and Rework. She collaborates with top research professors and advises organizations on how to use AI effectively to solve real-world business problems. And with that, Aishwarya, welcome to the community. Welcome to this evening, and over to you. Thank you.
Thank you. Thank you so much, Padmini. It's a pleasure. Let me do the screen sharing part now. Okay. All right. Always setup issues. Thank you so much for having me, folks. And I wanted to have a quick slide to do an intro, but I think Padmini kind of gave the best intro I could have ever asked for, so I will not spend a lot of time doing that. But today I'll be talking about MCP and giving you a very nuanced perspective about it, right? Everybody's raving about MCP, about interoperability and stuff like that. But if you've been working in the enterprise and if you've been using it, folks kind of know there are some bad and ugly parts to it as well. So I kind of had this title. I just thought it would be super appropriate to call it MCP, the good, bad, and ugly, right? So let's say you are in an enterprise or you are, just a hobbyist playing around with MCP. These are stuff that you really need to know and kind of understand in order to, work with it or build your own servers and stuff like that, right? Today's agenda will be pretty much this, which is I will spend the first 2 minutes aligning on what agents mean, right? Because sounds like nobody can agree on what agents mean. Everybody has their own definitions. Even model providers are kind of arguing on what agents mean. So I will tell you what I think agents are so that you're kind of aligned on my definition, and then we go from there. And then I will talk about tools for agents and why they're important and why plumbing these tools or engineering them, putting them together along with AI models is a little hard. And that's where protocols come into the picture, right? And then we'll go about explaining why MCP rose to fame, touch a little bit on other protocols that have been in this space. There are about 20 to 25 AI protocols, but MCP was the one that kind of rose to fame, and we talk a lot about it. And after that, A2A kind of got some momentum. So a little bit on why we think MCP was kind of picked up by a bunch of different folks in the enterprise. And then go to the crux, right? Which is the good, bad, and ugly of MCP and what you should be knowing when you build with it. So this is kind of my opening statement, which is everybody's building AI agents. I talked to a bunch of different founders in Silicon Valley. They're like, we are building agents for X. But then when I kind of go deeper, everybody seems to have their own definition. You'll generally see two branches or two schools of thought when it comes to agentic AI or agents. There's more of a business definition that you'll probably hear from C-suite and leadership and stuff like that, where they think of agents as autonomous systems that can take actions to achieve goals with minimal human intervention, right? Some format of this definition is generally used by the leadership. But if you talk to folks like me who are kind of building, who are AI engineers, or like folks who are, doing the work on implementation, you will hear a more technical definition, which is AI agents are basically LLMs with access to tools, memory, and they're tasked with planning and executing goals, right? And today I'll subscribe to the second definition because the first one can pretty much refer to anything, and it's hard to kind of draw an implementation equivalent to it. So I will be using the second definition, right? And another definition that I really like from Hugging Face is AI agents or programs where LLMs control the processes or workflows. And I will use the term AI models and LLMs interchangeably, although they're exactly not the same, but you kind of understand that these are generative AI models, right? This is kind of the picture I always bring when talking about agentic AI. 2022 was the year when ChatGPT kind of gained a good amount of momentum. And since then, 2022, 23, and 24, everybody was like, AI, generative AI is the biggest thing and things like that, right? Which was pretty cool. But then late 2024 or Q2 and later of 2024, we started hearing the term agentic AI or AI agents a lot more. And that's because of the fact that people started figuring out that Gen AI is cool and chatting with a bunch of systems is really nice. Our chatbots have gotten much better. But can we go a step further? Can we make them do things? Can we ask them to complete tasks that are a little more high level instead of them just answering questions for us, right? And that's when we came up with this notion of connecting AI models to a bunch of different components, right? And these are the three components that we generally talk about when we say AI agents, right? One is tools, which can be anything from code executors to APIs to calculator tools, or maybe requesting like HTTP requests to websites and things like that. Essentially, any external API or something that gives responses to the AI model. And the other thing that people started discussing about was AI models are stateless in nature, which means that they do not remember anything. If you pass, questions to them, etc., they cannot retain memory of that because they're just stateless. And when you're having conversations with ChatGPT, if it remembers things, that's because it's externally stored as memory. The model itself doesn't have any inherent notion of memory. So people started thinking, if you're going to be building AI agents that are going to be solving tasks, they need to have some form of memory. So we need to find ways to incorporate that and do that either externally or do some form of training on these models so that they could incorporate memory. So memory was another component that was heavily discussed. And the third thing was planning, which is, can you push these AI models to plan, to reason, to break down tasks and decompose them, right? And essentially what folks said is agentic AI is Gen AI with a bit of scaffolding that can help you, do things, remember what it did or remember your preferences, and also plan along the way, right? So this is where I get the image, which kind of says that Gen AI that is able to plan, remember, and do equal to agentic AI, right? Like that's kind of the definition I'll be using all through today, and wanted to make sure we're all on the same page when I use it. And there's been a lot of conversation now on the fact that AI agents and agentic AI might not be the same things and blah, blah, blah. But I do not think that definition or that distinction really makes sense. Others may have different opinions, but in all of my talk today, agentic AI will refer to any AI system that operates using one or more agents in some format, right? And a good part of why I spoke about agentic AI is because it gives us a lot of motivation on MCP itself and why it is required. This is just the same image that's kind of made into a horizontal format. And this is also to set the stage about how agents can plan, remember, and do. And a very simple use case that's generally given to explain agents is, let's say you want to book a 10-day vacation to Europe, and you're saying, you're asking this agent to generate a plan and then use necessary tools and memory and stuff like that to book that vacation for you, right? Think of this transition where chat systems were able to give you 10-day vacation itineraries, but agents are able to go and do that booking for you. And that's kind of what the kind of transition that we have seen going from generative AI to agentic AI, right? What happens is this AI model is connected to these components. The planning component is more of prompting or more of letting the AI know that it has to decompose tasks. The other two components, which are memory and tools, are external components that are connected through good old engineering, right? The AI model says, okay, in order to book a 10-day vacation, I probably need to retrieve the user's starting city and travel dates, and I need to maybe use Emirates API to search and book flights. Maybe the user has said that Emirates is kind of the preferred airline that I want to use. And based on the confirmed flight details, use booking.com API to find and reserve hotels, right? Like this is the plan it comes up with. And then it retrieves some information about the user itself, like which city is the user starting from and what dates are they planning their vacation. Maybe it's looking up their calendar and things like that. I'm not going too deep into the implementation, but just giving you an idea of how it could use details from memory. Memory is generally stored in typical SQL databases or vector databases and all of those. And then it uses tools, which are APIs, in order to make this booking, right? It probably queries Emirates API and says that these are the dates. I want to find the cheapest flights and makes a booking and stuff like that. So this is kind of how a typical workflow using agentic AI would look like, and how each of these components come into play in order to achieve it, right? So people were super fascinated with this idea, just the fact that instead of talking to systems, they could also go and do actions, they could break down tasks and stuff like that. And 2024 was really the year when people started picking this up. And agents obviously were thought to be much cooler than chatbots because they can plan, do, and remember. And a lot of focus, both in the enterprise and research, started shifting towards adding these capabilities to AI models, right? Which is the capability to plan, do, and remember. And now you could connect them to a bunch of different external tools, databases, and prompt them to decompose tasks in order to make this work, right? Now, as engineers and builders started building with these tools, they started seeing one major problem, which is each model provider builds their models in very different ways. The way they communicate with the user, the kind of abstractions that they're built on top of is pretty different. And each API also comes with its own set of parameters and stuff like that, right? So every time they had to make a connection between an AI model and a particular API, here I've just given an example of the Emirates booking.com and Gmail API, right? They had to build this custom connectors in order to connect these models and the APIs. And let's say we swapped DeepSeek, we were using Anthropic models and swapped it to DeepSeek, then all of this code had to change. Or if we moved from, say, United, from Emirates to United, then again, you had to kind of change all of these things, right? So there's so much engineering that would happen in order to connect to these tools. And that's when MCP kind of was released. And Anthropic was a bit early to release MCP. It happened in November 2024, and people were still playing around with tools. They were having fun. They're like, okay, agents are pretty cool. But none of them really got to the point of thinking that maybe if there was a protocol or if there was a standard of connecting these models to tools, then it might be much easier for us to build these systems, right? People were still struggling and they were just going on building. And if you really think of late 2024, agents were not very mainstream still. So when MCP released, it was pretty quiet. Like nobody adopted it. It was just a document on Anthropic's
You can count.
page. And this is an example to kind of say, if you have M models and N tools, then you need to build all of these M cross N connections between the models and tools without MCP. But then MCP is this standard or this way of telling how to build these connections so that you have M plus N kind of connections built in, right? That's pretty much the invention they came up with. If you strip down everything MCP does, it's basically a JSON specification to kind of say that APIs build your connectors in a certain way, and models build your connectors in a certain way. And it almost like your laptop and a charger, it kind of connects together, right? And all of them have a common connection mechanism. They also went to, and if you come from an engineering background, MCP uses something called as a client server architecture, which means that a server is serving a bunch of different APIs and the client is calling these APIs. The client basically is a large language model here because it kind of requires tools, and the server is anything like your Gmail or your booking.com or whatever it is, right? So the MCP server basically exposes tools, it exposes resources and also prompts, and the client kind of pulls all of this information. Also remember that anything that you can do with MCP, you could have done without MCP as well. Many people confuse the concept of MCP, thinking that MCP introduced tool calling. Because of MCP, you can connect to so many different tools. That is not true. MCP only standardized the way it could be called. So let's say Gmail tomorrow, comes up with a bunch of different updates. I don't have to write custom glue again in order to make those changes. That layer in between will take care of it, right? And let's say Stripe comes up with their own MCP server. The connection becomes much more easier instead of having to depend on custom engineering and glue and all of that. It's basically a community coming together as a whole and saying that this is how we're going to write our servers and clients, so that connection becomes much more easier. If everybody does it their own way, there is no common ground, and that's basically what MCP enables for a bunch of people. I love this diagram that explains what MCP does for AI systems, right? It's almost this adapter is kind of seen as MCP. It can take a bunch of different servers and connect that to clients. And client here is your LLM, which is sitting on top of a host. A host can be any application that the LLM is running, right? It could be anything like Claude Desktop, Cursor, and things like that. And in order to connect with all of these MCP servers, each of them maybe come with their own configurations, but MCP standardizes that in between. You can connect your local data sources, you can connect your calendar, your Gmail, and stuff like that, which makes it pretty simple. And like I was saying, in 2024, there have been lots of attempts to build stuff like MCP, which is to standardize, to make things more interoperable. This is a diagram from a very popular paper that talks about different AI protocols. And if you kind of see, the legend here says blue is LLMs, green is agent frameworks, orange is agent protocols, and purple is applications and platforms, right? And this is a timeline of what kind of things were being built in AI. You'll see that in 2019 until 2022, it was heavily a lot of building in the LLM space, and post that there was a lot of building in the agent framework space, right? You probably heard of LangChain, about Llama Index, and things like that. Once people had LLMs figured out, they wanted to build frameworks that could help you build applications from these LLMs. But once all of that was kind of settled to some point, 2024, people started building a lot of different protocols, right? There's a huge list of protocols that you can, I'll share these slides. You can also see that paper. So there's this thing called agent.json. There's also A2A, if you've heard of it, which is agent-to-agent communication. There's also something called Agent Network Protocol, which again is how do you communicate between different agents. Again, all of these are just protocols, or they are a set specification that people can use, and heavily depends, the success of this heavily depends on adoption itself, like how many people adopt it and how standard they make it, right? And MCP kind of took over all of this and was the most popular protocol to be used. And just a TLDR, if you feel like all of this, I don't really get the point of it, is protocols are as good as having a common language to talk, right? If let's say we have 5 different people, everybody talks in different languages, it's super hard to understand what the other person is saying, versus if you have one common language, which is English, everybody understands it, right? And that is MCP for AI systems. If you did not understand anything, this is one idea you can leave away with, right? The other question that maybe you're having is, why is it that only MCP took off, right? You told us that there's so many different protocols and so many people were coming up with this, both in 2024 and now in 2025 as well. Why did MCP take off? I think it's because of three major reasons, right? Again, if you talk to different people, they'll come up with their own reasoning. Sometimes it's very hard to understand why things take off, but this is why I think MCP took off, right? One is MCP was backed by Anthropic. Anthropic is a major model provider, as you folks know, and they made it open source, which means that others could contribute to it. And they did a very smart move of bringing on major application companies to adopt it, right? Companies like Replit, Cursor, etc., started using MCP, which means that they already had customers who were using it. And the way the industry works is when someone popular adopts it, you're like, oh, I want to check out what's happening, right? So adoption happened pretty quickly. And they also followed the client server architecture. Like I mentioned, client server architecture is pretty common in, REST APIs or websites and things like that. And they built on top of that. They did not reinvent the wheel, which made it super easy for engineers, builders to understand how it works, right? You didn't have to teach them all over again how these things work. So they built on top of existing transport layers. And the third reason is it had very clear documentation as compared to other systems, right? They had documentation, they had an open source repository, they had a bunch of servers that they, already had created. So it was easier for folks to onboard, right? So adoption and clean architecture and documentation is why I think MCP took off. A major reason is still the adoption, right? Any new protocol that comes tomorrow, if nobody adopts it, then doesn't matter how good it is, how technically elegant it is something that has to be driven by the adoption itself. Now, that's all this while we've been talking about what agents are, why MCP is needed, and all the good things that MCP can do, right? This is just a summary of everything that it can do. For instance, you can add tools to agents. You can no need to modify a lot of code, and folks who don't have a lot of building experience can also connect to these MCP servers and start working with them, just because things are standardized and it's easy to plug and play. And it improves with model quality, right? As LLMs get better, as they start getting better at understanding tools and stuff, MCP also improves with it. And not just playing around with these tools, you can build a lot of workflows, right? If you can connect to a Gmail MCP, then you can probably say, what are my emails? Can you reply to it and stuff like that? You can have your chatbot as the interface, or you can have like a workflow that you've built up and connecting to different, servers, which include Slack, Gmail, GitHub. Think of it, any different kind of API becomes far more easy. And because I've been going around talking for so long, I want to stop for a bit and show you a quick demo of Claude Code. Claude Desktop. This is something that I heavily use, and it's super easy for anybody to connect to a bunch of different MCP servers on Claude Desktop. Let me quickly show you this, right? So all you have to do is just there is this button here, and you just have to enable a bunch of different MCP servers, right? You say add connectors and it adds. You can also you can build your own MCP server and connect to it. I can also share a resource on how to do it. It's pretty intuitive. But let's say I do something like, tell me about text talks today. You can see my screen, right? The Claude. Okay.
Yes.
Awesome.
We can see it.
Yeah.
So if I say something like that, this is typical usage, right? People use Claude for all of these stuff. It's searching the web. It keeps writing a bunch of things. Now, one thing I've done is I've connected my Claude to my file system, which means that it can access all of my documents and it can also write to my file system. And that is an MCP server as a whole, right? Like, maybe when I showed you this image, remember local data sources was also something that you could add. So just that's an example. So what I say is, can you save this as a text file on my desktop, maybe? So what it's doing is it's actually accessing my desktop and it's writing to it. It uses the function write file to do it. And it saves a text file, right? Which is pretty cool, but not so cool. I think the cooler things that it can do is also just I've connected it to my calendar, which means that there is an MCP server for my calendar. Then I say okay, what meetings do I have today? So it's basically accessing my calendar. Again, I did not have to write any code for this. All of this is available. MCP servers are available to connect with your LLM systems, and you can also do it in literally 10 to 15 minutes. It shows a bunch of my meetings today, like I'm in this meeting. So just clarifying that it is actually reading my calendar, right? It says you have a busy day, blah, blah, blah. I could also go and say, add these meetings. I could also reply to my emails, which I don't want to do publicly, but stuff like that, right? It becomes a lot more easier to make things part of your ecosystem than being an isolated chatbot. And you can also use the MCP feature to build workflows, right? For instance, every time an email comes in from a prospective inquiry or something like that, I can pick up some FAQs from my database and reply to it and stuff like that. And everything that I'm doing is communicating with the Gmail MCP server, and it makes it much easier. That's a very quick demo of how you can interact with MCP servers and don't have to code at all. Having said that, that's the good part, right? Which is it makes it much easier to connect with a bunch of different services, and it reduces the bar for people to do so, right? Now I want to move more towards an enterprise practitioner perspective and give you the bad and ugly as well, right? What if you're building with MCP and what if you're thinking of building with scale? There are some bad components to it, which is MCP at this point has a very bleak user and developer experience. There's a high setup overhead for MCP. Given that you're using this client server architecture, in order to build your own servers, in order to connect them to the clients, there's a lot more code required as compared to building your own tooling, right? Definitely, it makes it much easier when you're adding more and more tools, but the initial onboarding is kind of fidgety at the moment. And it's a poor fit for lightweight apps. I've seen a lot of people go like, oh, MCP is the really cool thing. So even to add a calculator for my agent, I'm going to use MCP, and it's an overkill. It requires a lot of code to set it up on your own, and it's still evolving. The SDKs are still kind of evolving. The error handling is clunky. And all of this is assuming that you're building your own servers and clients, right? The example I showed you with Claude Desktop is the client is also ready, and there are a bunch of existing MCP servers. So connecting them is pretty simple. But let's say you're building your own server or you're building your own client, that's when things get a little more tricky, right? And it has a steep learning curve for developers in order to make sure that they build their own servers and stuff like that. So the dev experience at this point is kind of painful, but again, it's getting much better over time. And the other dimension to this is the performance, which is remember I told you that MCP makes it easier to connect to tons of tools, but then the way it does that is gives a list of tools to the AI model, and the AI model basically says, okay, there are 10 tools and this is what I think is right. Now, when I said, can you look up my calendar? What the client is doing is saying that the user has given me access to their local file system, to their Gmail, to their calendar. Now, calendar is what I should be looking at. In calendar, I should be probably looking at list user meetings or something like that, right? All of this information is given to the AI model in text, and generally models have this issue of struggling when given large context, and that kind of shows up in MCP as well. Just because you have the capability to add tons of tools doesn't mean that the models or the AI systems will work reliably with all of these tools. And that also leads to the second issue, which is the prompt gets super bloated, right? Because let's say you have 100 tools, you're filling all of that in the prompt itself, and the AI model can get confused. And the tool selection as remember, like if there are 10 tools, the AI model should select one of those tools and execute those tools. And tool selection accuracy at this point is pretty low. You have to play around a lot with how do you define these tools, what descriptions do you give them, and stuff like that. A lot of tweaking is required in order to get good performance, right? So tool selection accuracy is also pretty low. And there's also fragile JSON formatting issues and stuff like that, right? There is small deviations in how you have your tool call prompt, etc., can lead to issues with your system. Again, all of these are issues with tool calling itself. Like, it's not something that MCP has introduced, but I'm just kind of emphasizing the fact that just because you have MCP doesn't mean that these issues will go away. So these are stuff that still exist. And for us to treat MCP as a protocol where you could call, on paper, any number of tools possible is kind of still not there yet. Apart from the performance issues, there are a bunch of enterprise issues itself, right? Because MCP is very lightweight. It lacks any support for multi-tenant kind of use cases, right? There is no inbuilt support for scoped access, for role-based access, no user isolation and things like that. Companies have to build that on their own. And MCP also doesn't enforce any authentication. Like, it does provide some abstractions for OAuth 2.1 recently, but then again, a lot of the load has to be taken by the builders itself. There's also poor tool governance and observability. Like, sometimes if tool calls fail and things like that, you want to be having access to traces to understand where the tool is failing and what you can do about it. MCP out of the box doesn't give you access to any of that. You have to build your own observability around it. And there's no native workflow chaining and things like that, right? MCP assumes that every tool call is atomic, which means that if you have multi-step business workflows, you need to carry over that context and you need to do all of that orchestration and stuff like that, right? So these are generally the issues you'll land into if you're building MCP for enterprise use cases. So that's kind of the three dimensions where MCP still is growing: the developer experience, performance, and enterprise issues, right? These are the bad things, which is fine, because this is a technology, or this is a protocol that came about like not even 1 year ago. So obviously there'll be a lot more issues. There'll be a lot more blockers as we get to it becoming a more standard protocol. But then the ugly part is what most people are really concerned about, which is the security itself, right? Security threats are what I call ugly, because if companies start deploying using MCP and then there are these security issues, then it can be nightmare for enterprises. So I will give a few common issues that come with MCP, but there are like papers and papers of security threats that can take place with MCP, but I'm not going so deep because I just want to give you an overview of what could potentially happen, right? A very common issue with MCP is what we call as tool poisoning, which means that sometimes it's possible to give malicious tool descriptions and hide and have harmful instructions. They can also leak sensitive data without user visibility. MCP out of the box, the agent doesn't really verify if the tool is coming from, an authenticated MCP service, etc., because the agent essentially is an LLM, which is looking at text. So you could literally do prompt injections and things like that. All of that get a little more bloated up when you have tool poisoning attacks and stuff like that, right? So it is again on the it is dependent on the builder to make sure that tool poisoning and stuff like that do not happen. But this is a very common thing that can happen when you're building with MCP. The other one is called rug pulls, which is when you are connecting to an MCP server, everything is good with it, but later something can get updated in the MCP server. So there's an authentication mechanism, and after the authentication mechanism, you can poison the original MCP service, and there is no mechanism where clients keep tracking these changes, right? The client requests for information from the MCP server only when it requires something. There is no mechanism to keep monitoring what changes on the MCP server end. It treats it as an API and just calls in. So any change that happens in the MCP server, if it is poisoned or if it has malicious tool descriptions, etc., is not known to the client at all. So that's what is called as rug pull, which means you have the rug and you kind of pull it, showing an injected MCP service, right? The third one is what is called as shadowing attacks, which means that you could totally hijack this MCP server. 1 and 2 are just, small changes that you can make in the tool or inject them. The third one is completely control the MCP server. So you could completely control the MCP server, which means that you have someone, sitting there and continuously injecting prompts, or maybe getting information from the user, which is PII or things like that, right? For instance, this is an example which was send an email to someone, and the agent has stored your credentials in order to send an email, and it's possible that this MCP server is secretly taking your credentials in order to do this task, right? On the front, it looks like, okay, I sent an email to a particular person, but then inside it's probably extracting information and things like that. So these are three most common kind of attacks that are seen, and mostly has to do with the fact that the agent or the client keeps no checks on the MCP server, and it blindly trusts everything that's coming from the MCP server. And they could be attacks ranging from just some poisoning in the tools to completely remotely controlling the MCP server and the agent having no idea of it. But you could see how this can be much deeper. It can become much more nuanced than this, and could lead to a bunch of different security attacks, especially when dealing with enterprise systems, right? So as it stands, it's always recommended to use MCP servers that are built by providers of a service. For instance, if you're using GitHub's MCP server, use it directly from their trusted thing, or you could host the server within your enterprise itself so that you don't kind of have these security attacks and stuff. But regardless, this is a very less explored area of MCP. If you're building, toy projects and stuff like that, it's totally fine. You can connect wherever you want. But then when you move to the enterprise, all of this becomes super, super important. You're probably dealing with user data, you're dealing with PII, you're dealing with, finances and things like that. You want to make sure that nobody's able to access it outside your environment, right? So that's the ugly part. Having said all this, I will take the last 2 minutes to give you 5 golden rules for enterprise practitioners with respect to MCP. Again, this might change in the next 3 months, in the next 4 months. Anything that people tell you about AI, take it with a pinch of salt, because this space is moving so quickly, and neither you or I can actually say that it will remain the same. MCP is good. It's a work in progress. But then given the state of things as of today, this is what I would recommend you to do given my experience. But then make sure you keep up with the updates and don't really lock in with the same golden rules, right? Remember that protocol battles will take time to settle, which means that MCP came up, after that A2A came up, and really the way Google pitched A2A is that it can work with MCP, but then people who work heavily with AI know for a fact that they're actually overlapping quite a bit, and A2A wants to probably take over MCP at some point. Somehow it never kicked off because agentic systems, multi-agent systems are a pain to make them reliably work in the enterprise. And that's probably why I think A2A did not kick off. But in the next few months, you'll see a bunch of different big players come in and say that we have our own protocol, it's better than MCP and things like that. And even today, I can't tell you if MCP will be the protocol, if it will be the HTTP for AI. But remember that you need to build with agility and not really lock in. And adopt protocols only to reduce your integration debt. Do not rush to using these protocols. And whatever I'm talking is for enterprise practitioners, right? If you're building toy projects, you don't have to worry about all of these things. So if you're building your V0 in the enterprise, then you don't have to be like, oh, I need to use MCP because everybody's using it and stuff. Really think about whether it's required. How many tools are you calling? Can you do much more lightweight and not really spend a lot of time building for MCP, right? Protocols or anything like MCP matter the most when your system uses external tools or when you are exposing external tools to people, right? If everything is within your enterprise ecosystem, there's not really a huge need to build with MCP unless your further vision at some point is to expose it, right? So really think of it in that way. And one of the biggest mistakes that people do when they build with MCP or with protocols is that they think they're software pipelines. Generally, LLMs are very good at understanding natural language. And so when you're giving your tool descriptions, when you're explaining your resources and all of that, natural language descriptions really help. So make sure that you're building and designing with agents in mind and not software pipelines. That's something that significantly helps improve performance. And remember again and again that protocols at this point are not secure by default. If you're building for the enterprise, you need to add your own guardrails. You need to enforce your own authentication. You need to build your own logs. And all of these things should be done by the enterprise practitioner itself. any kind of tampering should be caught. So security practices should be super high when you're building either servers that you're exposing outside or you're calling from external servers, right? All of this is somehow the pressure is put on the practitioner itself. So just knowing that I can't just randomly go and call an MCP server and assume that it will work well really helps, right? You need to make sure that your security practices are also in place. Having said that, I will end and take questions.
Wow. That was phenomenal, Aishwarya. Thank you so much. So we have a few questions in the chat. So I think first one is from Prakash. Prakash, you are more than welcome to go off mute and ask your question. And then I think next we have Lalit. And yes, Evan, we see your hand, so you would be number 3.
And then we have Gautam.
Yes. Prakash, are you there? Do you want to go off mute?
So Aishwarya, I'll just read out the question.
Yeah.
He says, so without MCP, we can't do these things, right? Sorry, I'm a bit new to the world of agentic AI. So it was
must
with
be earlier slide.
If you
Uh,
so if you go back in your slides.
Can you see my slides though?
No, right now we are still seeing your server, the Claude server, your calendar.
I see. Let me figure it out. Now?
Yeah.
Yeah.
Okay.
So if you go back a few slides and we go back to the good.
I wish we could stay in the good.
Yeah. So I think around here was the access to tools and connecting to all like Gmail and calculator and all that. I think his question is around that. So if we do not have an.
So again, we can do everything that we can do with MCP without MCP, right? So that's the baseline you need to go with. The way you would connect to tools before MCP was a thing was to write your own, APIs, to write your own. Let's say AI says I'm going to have to run a SQL query, which is user city equal to DXB, destination equal to LHR. What this custom engineering part does for you is it takes the response from the AI system and executes it, right? There are remote code executors that you can run and it executes it for you. The only issue is the fact that this custom engineering that you've built should be able to understand what is the response format here and what is the request format here. It figures out that. MCP only makes it simpler because it standardizes the request format and the response format. That's pretty much it. So anytime people tell you that MCP is inventing something new, that is not true. Everything that you can do with MCP could be done, but it was just more clumsy before.
Great. Thank you. Lalit, do you want to ask your question, please?
Sure, yeah. First of all, thank you so much. This was great. Thanks, Aishwarya. And my question was around when you start adding different tools, right, to the MCP server, like you mentioned, it gets bloated, which makes sense, a lot of sense. But how do we solve that problem? Can we have like multiple parallel MCP servers running if it gets to that complicated state?
So one thing, Lalit, is MCP servers can have different tools. The bloating issue happens because these AI models receive all of those tools, right? And AI models have a very fixed context length. So the bloating is happening at the model level, not at the server level. Let's say there are 10 MCP servers with 10 tools each. Now the model kind of has to see all of those. Like it is seeing 100 tools. So it gets a little confused on which tool I should be selecting. And all of these tools have their descriptions and you quickly run out of LLM context length. And one way people generally resolve is to add some form of routing or orchestration, which is, let's say the question is about planning a 10-day vacation, right? Then the first step would be to just bring in only required tools, right? Whenever there's a flight booking kind of thing, I bring in only Emirates and United's MCP servers. I remove the rest of them so that it makes it much easier. So basically decomposing the task into multiple parts so that the bloating is somehow solved. But otherwise, there's not really much you can do because you're going out of the context length, and the only way is to kind of break it down into parts. Like if there are 100 tools, narrow down to 10 tools and then go a little further.
Okay.
That makes sense.
Get it. Yeah. Thank you. Makes sense. Yep.
Evan, would you like to go next?
Yeah. First, thank you for all this is such good information. It's so much to absorb, in 1 hour. But
Is that a compliment or a complaint?
no, it's good.
It's good.
We need a part
No,
two.
just kidding.
We need a part two. But do you, if you have, is it better to keep 1-to-1 ratio between agent and tool? If you had, that's part of my question, because if you had 10 tools and 5 agents, isn't it better to match agent to tool 1-to-1 like that for performance instead of fewer agents, no matter how many tools you have?
It's always a trade-off, right? Because if you bring in 10 different agents, then whenever a task is given, you still need to make that decision of which agent should be performing this task. And ideally, you don't want to underuse an agent, which means that if an agent is able to handle 10 tools, why underuse it? Why are you building multiple different agents? It's a lot of, infrastructure blow up. It's a lot of complexity. So I would agree that at some point, maybe you want to divide roles. You want to do some kind of, modularization, but not do it very preemptively, because still the decision has to be made somewhere. This routing example that I was saying, which is if there are 10 different tools and 10 MCP servers, then you could route it. Then maybe with respect to what you're saying, maybe I can do that routing decision beforehand itself, right? Like I can say that there is an agent that takes care of only flight bookings, and that is connected to only flight MCP servers, right? That's a routing decision that I've made. But why would I want 2 agents, one for Emirates and one for United? Because at that point, again, that decision has to be made anyway, which of them I'm picking. So it's kind of very use case dependent on where you want to make that decision, whether you want to make it on the fly or you want to have agents for specific tasks.
Yeah, that makes sense. But don't you think people over-engineer when it comes to MCP? I talk to developers who say they want to do MCP, they want to do agentic RAG, they think that they have to do everything in their workflow. But I tell them to start simple, right? So can they do the whole thing even without MCP or without agentic RAG? So do you caution people to start small or just, it's hard to tell them how to develop,
So
right?
I have created a bunch of courses, and one of them says building AI applications with a problem first approach, right? So you couldn't have phrased it in a nicer way, I guess, because I'm always this person who says start small when it comes to AI, because it's non-deterministic, and never start with the technology. Don't say I want to do agentic RAG. I would always say, what is your problem? What do you want to solve? Is agentic RAG the right thing to do it? And even with MCP, like I was saying, if you're building tools within your ecosystem and you don't have any intention to expose it externally, then do you even require MCP? If you're just using a calculator and a weather tool, it's much quicker to build it without this MCP abstraction in place. So really walk backwards from the problem. And I would always recommend folks to even narrow the scope down and build iteratively, because AI is that one space which is very different as compared to software engineering, in the sense that it's very non-deterministic, right? As soon as user behavior changes, the way AI reacts to user behavior also changes. So you really need multiple iterations to get to, a more complicated use case. So always do iterative and never start from the technology. Start with the problem that you're trying to solve. And only if your problem demands a particular technology, then go for it, right? I would always say, like, if you want your AI to do something, then add a tool. If you want your AI to bring in additional context, then use RAG and stuff like that. But agentic RAG at the get-go, I want to really know why you want to pick that up before you say, I want to use agentic RAG to build X. So definitely agree on everything that you said, and I kind of really stand by that idea of build small and go iteratively and really use your data to build flywheels, to understand, to get some evaluation metrics on where you want to be headed, instead of starting very huge, adding 10 times of agents, and then you're just stuck debugging all of this.
Right.
That's
Right.
great
Okay. Thank you.
advice. That's
Makes
very
good
good.
sense. Thank you.
Yeah, we have 3 more questions that came up. So I think Gautam was first, then we have Dipesh, and then SN. So Gautam, if you want to quickly go off mute and ask your question.
Hi, firstly, thank you for the session. And in the interest of time, I just wanted to understand if NA10 or the Copilot Studio, do you consider those as the AI agentic platforms or more of an AI automation workflows? And also in the Copilot Studio, I see MCP, but given the use cases like you mentioned about problem first, if it is not more user facing but only internal team facing, do we have a use cases where MCP would be critical in those situations?
I'll answer your first question, right? NA10 started off as an automation platform, but now they allow you to build agents as well. Like I said, right, it really depends on what is your definition of agents. Like if you're on NA10, you can build a workflow. Like if I get an email, look at that email, and let's say I'm running a business. If it's from a prospective client, reply to them with a particular answer. At this point, do we call that an agent? Yes, because it's kind of, using Gmail tools, it's making a decision on how to reply and things like that. So I would call NA10 a superset of agents. Like they allow all kinds of automation and agentic automation as well, because they're using LLMs to make those decisions. Again, I'm this person who's really frustrated with jargon, so I don't know. I just break it down and say, this is what it does, this is what it doesn't do. Now you tell me what the jargon is. I don't really care. And your second question was, Gautam? I'm sorry, I
Um, yeah, so
got carried away.
regarding the Copilot Studio, the MCP is
Right.
integrated in it. Uh, so what
So,
kind of enterprise
if
use case? Yeah, go ahead.
So again, like MCP, it depends on what servers you are kind of using, right? For instance, let's say Outlook is an MCP server. You can connect that with your LLMs, and just the use case that I told you of automatic replying can be achieved with it. But let's say you are building your own servers in the enterprise, then you really need to think about, are other teams going to be using your servers, or is it going to be used externally and things like that. There are two parts to this, right? You either use a server as a client, which is like Claude desktop using Gmail and stuff like that, versus you think of yourself as Gmail, which is you're offering a bunch of different tools for people to use. So um, maybe the follow-up that I want here from you is, are you thinking of yourself as a team that is building servers, or a team that is using servers from a client perspective?
Using the servers, but not creating a custom MCP. So using the existing ones. So what kind of use cases do you consider where we can create MCP servers if we don't find one of a MCP server we want?
What kind of use cases can you create MCP? Again, doesn't it really depend on the APIs that you're using as of today? Because MCP is just a scaffolding on top of API, right? Like let's say you're using Salesforce heavily, right? And you're going and making changes in the Salesforce UI. You can build an MCP server on top of that so that you can chat with your Salesforce system. Or let's say you use SQL databases very heavily, and you have a bunch of data scientists or like domain experts who do not know SQL very well. Then you can have an MCP server that just looks up this database, takes natural languages input, generates SQL, and then comes back to
Okay.
you with the answer, right? A bunch of these data analysis, all of that can be simplified. Again, think of the APIs you're using as of today. Can you
Mhm.
make that much simpler? Like instead of an engineer having to write, tools and, APIs and stuff like that, can you build a natural language interface to it, or can you build a simpler interface to it? Then maybe think of building, again, like MCP server is not required here. You could also build a tool calling kind of capability, but
Right.
if
Yeah.
it's being used by a large group of people and people are adding to it, then build an MCP server around it.
Okay, got it. Just to declutter, the access
Exactly.
to.
Just to
Got it.
standardize, right?
Got it.
Like, let's say in your company, everybody's building their own tools, own connections. It's like really clumsy. But if you have that one server, like let's say your data analysis server, which is connected in the backend with a bunch of different databases, it makes it much easier, right? Instead of having, scattered things.
Understood. Yeah. Yeah. Thank you for that,
Awesome.
Aishwarya.
Thanks. And I think next we have Deepesh. Deepesh, do you want to quickly go off mute and just ask your question?
Yeah, thanks, Aishwarya, and thanks team for having this wonderful session. One thing which I would like to ask, and this is more with respect to AI governance. Now, let's say, I mean, right now there are a lot of tools, N10 and Lovable, and so on and so forth. How does you think how do you think how these systems, or I would say this orchestration automation tools, can be included in the managed services through GCP, AWS kind of thing, wherein we can bring in all those tools within the components and tools available and make it simpler. So now here the question comes from the AI governance perspective, because and the safeguards and privacy and so on and so forth, because those are independent tools. So how do you think will it make it more difficult if we get these tools from the MCP protocols and all, and how complex this entire thing would go if you want to create an end-to-end solution?
I see. Again, now this depends on how strict the governance is in a particular vertical. For instance, if you are in a health vertical or a finance vertical, governance is much more stricter as compared to, say, retail or something like that. But a lot of these automation options give you the ability to self-host. Like N8N also has its, open source repository that you can self-host within your own ecosystem. So that's a very simple direction that a lot of enterprises take, because that way you're not exposing any data. Having said that, there are also enterprise licenses which give you safeguards and privacy and security guardrails that you can use. But depending on the level of governance and level of data criticality and things like that, you need to be thinking of whether you want to do that self-hosting or whether you want to go ahead with enterprise licenses. But doing self-hosting is not such a huge pain point.
Yeah, thanks a lot. Thank you.
Okay, we have two more. So, and thank you so much, Aishwarya. I hope you're okay just going just a couple of minutes over just to answer the questions. That's okay. So next one, I think SN, do you want to quickly go off mute and ask your question? And then we have Ramya waiting.
Yeah, I'm not sure whether I'm audible enough.
You're fine.
Okay, great. Thanks, Aishwarya, for this great presentation. Just wanted to check on whether you think the bad and the ugly could somehow be addressed by implementing an API gateway together with an MCP server.
What was the first part you said? I missed your first half of the sentence.
So can we kind of stitch together an API gateway with an MCP server to
Yeah,
kind of
that's pretty much what MCP is, right? There is an API gateway, and now you're exposing that as a tool to the LLM. So that's pretty much what it is. Like even this Gmail thing that I was showing you, those APIs already exist, but you're kind of displaying them for the AI model to select, and you're also interacting with those APIs itself. MCP is just like the standardization layer. I'll stop to see if I understand your question right.
so there are the bad and the ugly that you pointed out, right?
Mm-hmm.
And an API gateway already addresses those bad and the ugly, right? So if we kind of together bring this together with an MCP server, where uh, a REST connection or a JSON over RPC is actually the protocol translation is happening, or at least the API gateway doesn't work on the protocol translation at all and just passes the content in JSON over RPC. You could use the rate limiting, the security, the RBAC controls from the API gateway to kind of do away with the bad and ugly of the MCP.
That is true, and MCP is built on top of JSON RPC. So that is the transport layer it already uses. The issue still being that the thing is with replacement of tools, right? Like the gateway itself can be affected. That is where the bad and ugly comes in, right? It's not about the fact that once you send a request, something's happening with it. Just the fact that the wrong tools are being exposed or this MCP server is being affected. That's where we have issues, right?
Okay. Sure.
And I think, thank you so much. And last one, I think Ramya. Ramya, thank you so much for your patience. Go.
Yeah, thank you so much for this session, and thanks for taking my question here. So my question is around building scalable agentic workflows. So in an enterprise, when you have like multiple tools in a workflow and you have like external APIs, so is there any, like, does MCP handle rate limiting? Does it have any support for managing the retries, or is it entirely dependent on the engineer to manually handle it?
At this point, rate limiting is not something MCP supports. You need to build your own scaffolding around it. Sometimes if it doesn't find a tool or something like that, again, you kind of implement, right? If after 5 tries or something, you want to stop looking for tools and stuff like that, there is nothing at this point with MCP. It's just this standardization that helps you communicate. Everything around it is something that you need to be building.
Thank you.
Do we have any other questions? Probably not, right?
Yeah.
I think everybody's really thrilled with the session, Aishwarya.
Oh my
So,
God.
yeah,
This was
amazing.
amazing. Well, thank you so much. Please feel free to connect with Aishwarya. I think everybody knows her. And Padmini just threw in the chat the link to our community. So if you are an Asian woman, please join our group. We have lots of these amazing sessions, and hopefully Aishwarya is going to come back again to speak at our session soon. And yeah, thank you. And then the last thing we wanted to remind you today is that we have a roundtable coming up. I think it's on the 21st or the 22nd, right?
21st of July at 8 p.m.
Fabulous. And it's going to be on an exciting topic.
Yeah, we'll be discussing the paper that MIT has released about we losing our thinking power to AI. So do join us for that roundtable. And Uvika, why don't you go ahead and close us out?
Yeah, that's it. So look out for the invite. We'll be posting the session soon. So yeah, I think it'll be an interesting discussion. There are a lot of various viewpoints on that topic. So do make sure you come. And yeah, thank you so much for joining. And I hope you have a great evening.
Thank you, Aishwarya. Thank you all.
Thank you, Aishwarya.
so much.
Thanks, everyone.
Thank you,
Bye.
Thank you. Thank you,
Good night.
everyone.
Bye-bye.
Thank you, everyone. Bye. See you.